Good morning, everyone. So I just want to start off just a quick apology. One of our panelists, Ariel Ekblaw, she came down with the flu yesterday, so unfortunately she will not be able to make it. But we have still have an amazing panel for you. So leading off today is going to be the Space Infrastructure panel, talking about the current state of the industry and the future of in-space service assembly and manufacturing. Our moderator today is Professor Zachary Cordero, who is the head of the MIT Aerospace Materials and Structures Lab. And he earned his Bachelor's of Science in Physics and his PhD in Materials Engineering at MIT before doing his postdoctoral work at Oak Ridge National Laboratories and becoming an associate professor at Rice University, and then before joining the staff at MIT, where he currently leads a lab and is a wonderful professor here. So without further ado, I'd like to bring our panel aboard and hand it off to Professor Cordero.
So, yeah, Andy, where are you at? Bright lights.
It is really bright.
Yeah. So wanted to start with brief introductions. Andy, you want to kick us off?
Well, I think I came from space just now.
Okay.
By the way.
You landed.
Just barely.
Yeah.
Don't trust Google Maps ever.
Okay.
It's always plus or minus 3 or 4 miles. So.
Just getting your steps in.
Yeah, out of breath, actually. But he told me they'd fill this with vodka, so I should be okay.
Good.
Yeah. You want to know who I am?
Yes.
Okay. I'm Andy Quass. I am a NG Fellow 2 for Northrop Grumman. A lot of people don't know what fellows are in industry, and it's a little hard to explain. And at Northrop, after you get about as high as you possibly can in the technology field, you become a tech fellow. And from that, a small subset go into an NG Fellow, which is corporate-wide. And then a very small set of that goes to an NG Fellow 2, and I'm luckily one of those. So there's not many of us in the company, but it must mean something, right? So I've been with Northrop 45 years, started in 1980 as a graduate from University of Michigan in aerospace primarily. Hey, how come we're not in the NCAA finals of basketball? Just saying football, that's all it's all about. So yeah, over those 45 years, I've done quite a few things, all space related. Right now, I head up all the additive manufacturing for the space sector. There's 4 sectors in Northrop. And in the space sector, I head up the AM work with another fellow. And also I'm responsible for overseeing a lot of the satellite development activities. And fellows at Northrop, that's basically what we do. We don't focus on any one program. We're basically there to search out where there's a problem and fix it, and then get off. Get off the program. Just kind of support things as needed.
Great.
So,
Okay.
I'm also a research professor at the University of New Mexico.
Excellent. And then Alex, can you introduce yourself and also Starship?
Yes. So
Or Starfish, sorry.
Starfish Space. Yeah. It's okay. We get that a lot.
Yeah.
So it's so great to be here. And Andy, I wonder if we were just on the same flight. I've spent about the last 2 hours on the tarmac at Logan.
I came in last night. Yeah.
But yeah, Alex from Starfish Space. I'm the director of LEO Business and Policy at Starfish, which is a satellite servicing company. So given that we're on the infrastructure and ISAM panel, that sounds pretty good to me. I've been at Starfish about 2 years, so seen the company almost quadruple in size to 53 full-time employees as of this week, which is pretty exciting. Prior to that, I was working in another commercial space company, NanoRacks, focused on human habitation platforms with the Starlab space station, with a very similar role in business and policy. And prior to that, I was a aerospace security policy researcher at one of the think tanks in DC, where I live and work now. And that was at the CSIS Aerospace Security Project. And I understand we had a couple CSIS Aerospace Security Project folks here at MIT throughout the week, Caitlin Johnson and the newly minted Dr. Thomas Gonzalez-Roberts. So
Great.
We also have quite a few MIT folks at Starfish. And I saw our former intern, Victor Quinn, here earlier this morning. So good to be here.
Yeah, so can you, so at the very start, I'm going to emphasize that ISAM, OSAM, this topic has been evolving very, very quickly over the past several years. In fact, the name has evolved.
Yes.
So like 4 years ago, people were referring to OSAM. Now I think it's ISAM.
Formerly on orbit,
Yeah.
now expanded to in space servicing, assembly, and manufacturing, I believe to capture the idea that on celestial bodies would be a great place to do these activities as well.
Yeah. So I wanted to start actually by discussing, like going through actually in order, like the servicing, assembly, and manufacturing. So can you each discuss your perspective on commercial opportunities and in-space servicing and like near-term opportunities and then also longer-term vision?
Yeah, let me jump on that. You know, I think I wish I was Alex's age again, you know,
Yeah.
because we're at the beginning of what is going to be just a whole new era of space activities because of the servicing aspects of it. I mean, it was not a decade ago when we didn't have our servicing vehicles even on the drawing board yet, where we visioned a time where instead of replacing a satellite, we would just go up and fix it, right? And the ability to get there has not been trivial. It's been very tough. We've already demonstrated 2 on-orbit attachments to Intelsat 905 and 1002, but it's not an easy. I could explain all the problems that we had to get to there, and I think people have to realize that when we look back in the 2020s timeframe, it really was the beginning of a whole new era of things we can do in space because of the servicing, because of the persistent platforms that are coming, and because of the ability to not order another $500 million satellite, but hand me 50 million. Don't quote me on any numbers, by the way. And I'll go up and fix the one you got.
Yeah.
Right? I mean, that's just.
The audience may not
blows
be
me away.
the audience may not be familiar with Northrop Grumman Space Logistics and
Yeah,
MEV
Space
and
Logistics is a subsidiary of Northrop Grumman. We do a lot of things with regards to refueling. Bucky DIU's helped a lot in that. We started Space Logistics, I guess it has been 10 years now, 2014, as a subsidiary to develop a servicing vehicle. And it took many, many years to get to a point where we did 2 attachments, first to Intelsat 905 that we took out of the graveyard orbit. It was a great satellite. In fact, I think we built it, matter of fact. But it ran out of gas, quite frankly. It was out of fuel, and all the sensors were working fine, power system was working fine, everything was good. It just couldn't stay in its orbit. So we, for a certain amount of dollars, I won't mention the amount, went into the graveyard orbit, grabbed it, put it in a new orbit, and stayed with that with our mission extension vehicle. And it's still attached to this day, 3.5 years later. And then a year later, we did it again to another Intelsat where 1002, where this one was hard. This one was actually in orbit transmitting the World Cup. And the owners of that satellite said, whatever you do, don't mess up the transmission of the World Cup.
The first global riot.
Yeah, it would have been a
Very
real
important.
bad day, right? And so it's a funny little mini story in that we got into the capture area in where we were supposed to be, and according to our system, everything was fine. Go in and grab it, do what you got to do, and be happy. Intelsat said, no, we're noticing some perturbations in our spacecraft, and we're just concerned that when you go in, if you don't get it right, and that system is based on going right up the liquid apogee engine and grab it from the inside, suck it back in, and do what we need to do. So there's some risk. We were comfortable with it, they weren't, so we waited and we stayed, in that capture box for several orbits before we got to a point of confidence from them that we were going to be okay to go in and get it. And we did, and now it's been in orbit, a new orbit, for about 1.5 years. So again, 2 satellites that were virtually dead, right? Out of fuel. Bodes well for the refueling argument, doesn't it? Both now are very functioning. We're staying with them for 5 years, and we're already starting to plan what we do with those vehicles after their 5 years is up. So yeah, Space Logistics has been a pioneer in space logistics, should be with a name like that. And I'm happy that there's others. There's more than one automaker out there, right?
Yeah, yeah.
So there's going to be more than one servicing company
Yeah.
10 years from now. And we're totally, accept that and think that's a great idea.
So Alex, can you speak to your perspective on commercial opportunities and longer term vision?
Yeah, I think I want to talk about the history,
Yeah.
where we are now, and what's next. But I think that at Starfish, we talk all the time about how awesome is it that Northrop Grumman Space Logistics is the first one to have ever performed a commercial life extension service like this, paving the way so that people understand that the market exists. And as you were saying, a variety of providers can work, cooperatively, hopefully, to, provide many different options for every need. As we said, this is the first ever commercial satellite servicing mission, but not the first ever satellite servicing mission, right? And even before Hubble, which, billions of dollars, had to do it over and over, took a bunch of humans to complete the mission. We even had, in the 80s, the Solar Max satellite was serviced by humans and brought back to life there. I don't remember the exact year. Anyone who can tell me the year, I'll give you a Starfish remove before flight tag. And something that I think is so beautiful, Andy, about what you were describing about Northrop's solution for actually grappling the spacecraft is you had to figure out how to do it with a spacecraft that was not built for servicing to begin with, right? Innovating hardware that could work with whatever hardware was already up there. And that's the approach we're taking at Starfish Space as well. I know that there's approaches on the market that are trying to figure out compatibility for the future, so we don't have to go through all of this almost reverse engineering years and years from now. And that might be really useful as well, and standardization certainly has been great. Right, in automotive, I can drive any car of any make or model to any gas station and fuel it up. But what about the satellites that are flying today? None of them were built with docking in mind, maybe until very, very recently. So I think that in order, as Cameron was saying in the intro, right, I think today is all about the economics and the business case. In order to address the market today, where clearly a need exists for servicing and logistics, moving satellites from here to there, both in LEO and GEO, it's our responsibility as satellite servicing providers to come up with a way to dock with satellites that were never intended to receive docking and to receive services. At Starfish, we have a universally compatible, what we're calling hardware agnostic end effector called Nautilus that we believe can dock with any unprepared satellite. And hopefully we'll demonstrate that next year in orbit. But after initial capabilities that may be fairly rudimentary compared to a sci-fi future where we can assemble things and take them apart and recycle them and refuel them. How do we bridge the gap from simple docking and docked maneuver to that future? And I wonder if that's what your future questions will be, Zach. But I think the business case today is moving things from here to there to give operators more flexibility. I think what we're really selling, probably to your point, Andy, is flexibility. The flexibility to delay or defer the cost of building another spacecraft on the ground because your GeoBird failed, or maybe not failed, ran out of fuel. And
yeah. All right, so I believe that space logistics and Starfish are focused on different segments of the in-space servicing market. So space logistics, primary missions have been focused on GEO, and I think Starfish is mainly focused on LEO. Is that correct? Or
we work both in LEO and GEO.
Okay. So where do you see the opportunities in LEO?
Yeah, great question. I'm the director of LEO business at Starfish. Maybe we'll bring the GEO guy next year to the conference. I like to say that our business case in LEO closes more and more as constellation size scales up. In LEO, obviously, if the LEO so-called mega constellation providers, although I've been told they don't like the word mega, are going to compete with GEO providers, we all know that they need intensely proliferated constellations, right, for universal connectivity. The advantage is you can see everywhere and talk to everyone at once. The disadvantage is if even one of your spacecraft becomes derelict, it could potentially pose an existential risk to the entire potentially billions of dollars of infrastructure panel that you just invested in and just launched. So why I say our business case closes more and more as the constellation size scales is if you're only flying a couple spacecraft in LEO, like, okay, even if my propulsion system has failed, maybe it won't crash into my own satellites, right? But if you're flying hundreds or thousands or tens of thousands, then even a couple that are drifting in your own orbital planes, that's when it might become more economically feasible for you to pay a service provider like Starfish or some of the other LEO servicers on the market to just pluck those one or two out of the way to preserve and protect the rest of your investment.
So it seems like fundamentally different approaches here, where GEO, it's reviving assets that may be end of life, and LEO, it is kind of pruning a constellation, making sure it's safe for the...
No, I think the GEO market as well, and by the way, we also are looking, cislunar and beyond. So, but the GEO market as well, as the next vehicle we're developing, the mission robotics vehicle, which is essentially an MEV with the NRL RSGS robotic system on board to be able to have the robotic capability to do a variety of things. And so we've gone through simulations, and we've got a RPod lab the size of this room to go and do full-size, offloaded, simulations of how this thing's going to work. And so we're able to, our plans are to be able to do a variety of things to go in and repair a satellite. A satellite may have a broken, or maybe a solar panel didn't completely deploy. So with my MRV, I'm able to go up, inspect it first and see what's going on, pass that information back, or better yet, do onboard AI diagnostics of what needs to happen and then just do it. Don't wait for man to be in the loop, right? Always think if we're going to screw it up, it's going to be done by a human. Let the AI take care of doing it all, right? So that system goes in, does the inspection, realizes where it needs to grab, and shakes the thing loose, and the rest of the panel deploys. Or actually be able to deploy a new solar panel on top of the failed one. Maybe it's been hit by meteorites or just damaged to a point of not functioning. We can go in and repair it. Now it gets complicated, and we're doing a lot of work with surgical robotics, where if we have to go up to a satellite, peel back the mylar, cut and peel back the mylar, and go in and do something and replace a system or a subsystem or component, we're intending to be able to do that as well. But the MRV has a partner called the MEP, Mission Extension Pod, that is a miniature version of something similar to the MEV, does not have its own onboard guidance and control. We rely on the satellite to have its own. So the price goes down dramatically, right, for an MEP installation on board a satellite to be able to, again, do life extension. And so the MRV, the Mission Robotics Vehicle, can do servicing, can do refueling, can do total upgrades, or just if I have a system that was designed way back in 2022, and by the time I get up there to fix it, it's 2028, the system is probably upgradable. And so if I'm there, I'm going to go ahead and replace that star tracker or whatever the case might be, and put that satellite right back into service for X number of years. Pretty exciting stuff.
Yeah. Can you speak, so I think both of you have emphasized commercial customers, companies deploying mega constellations, Intelsat, broadcasting World Cup. Can you speak to the role of government money in advancing servicing technology, and especially in light of recent cancellations of OSAM 1, OSAM 2? So,
Rest in peace, OSAM 1.
Yeah.
Yeah, those are the OSAM 1 and OSAM 2 are difficult case studies. The companies responsible, Maxar for one, basically, and Redwire for the other, did a fantastic job to get done what they needed to do. Certain circumstances occurred that NASA felt it wasn't worthwhile to continue, and I think that was a justifiable decision. But there was lessons learned there, and so it was valuable to everybody in the industry. But I think people got to realize this is not easy. If it was easy, we'd have done it years ago, right? So there's going to be some failures along the way, and the customers, certainly commercial and civilian customers are a key piece of it. But frankly, I think the DoD is going to end up being the biggest customer. And that's why people like Bucky with DIU and Space Systems Command have invested in our work on the PRM and the refueling activities that are going on. So far, it's been very successful to get to that point. And whatever customer comes up to require that service, whether it be refueling or repair or upgrade or whatever the case might be, I think at the end of the day, the majority of the customers are going to be DoD. And obviously, we're not going to go into what those missions are. But, but you can kind of figure that out.
Yeah, I mean, certainly the DoD has a lot of assets up there. I like to think, like, our real question is, what is the role of government? Historically, the government has been an early adopter and, early investor in a lot of technologies that are dual use, right? We all understand that the ability to autonomously rendezvous, dock with, and then move around another satellite is an inherently dual-use technology. So I think it makes sense that the DoD is a big investor in. I mean, obviously, the DIU, as you just mentioned, invested $3 million in our Nautilus capture mechanism over the last couple years, which is really exciting. I don't want to see a future where commercial companies become over-reliant on defense money and defense customers. I would love to see a future where we are commercially sustainable, regardless of the split between our commercial customers and our defense customers. Figuring out what the right balance is always going to be tricky, especially because we want to use our capabilities to meet national needs for sure. But I've always been fascinated by the challenge, I think, of understanding commercial incentives. In the government, admittedly, government customers are moving more and more towards purchasing services rather than acquiring, bespoke, one-off, huge, exquisite satellites. And we saw over the last week, John Plum from the Office of the Secretary of Defense announced the OSD's Commercial Space Integration Plan. And later next week, we're anticipating the Space Force will drop their commercial space integration strategy as well. Conversations that I have with Space Force stakeholders go like this. Why should we buy your commercial service when there's risk involved because you're a startup? And then I say, well, there's risk involved, but there's also risk involved in not purchasing our services, right? If we can move more quickly and provide potentially a similar or improved service much more affordably. And what I'm trying to impress upon stakeholders in the DoD is if you want capabilities that are tactically responsive and can meet needs to impress upon adversary nations that we have similar or superior capabilities on a tactically responsive timeline, you have to give something to get something. You have to risk something to gain the benefits of commercial innovation. And it's encouraging to see certain offices within the DoD moving that way, but I think it will require a long-term culture shift until we see really heavy and routine adoption of of services and capabilities, rather than hardware. We want to own and operate our own Otter spacecraft as we perform these services for customers, whether they are commercial or defense, whereas the traditional procurement model is, let me buy that Otter from you and operate it myself. So hopefully that's a little summary of the Starfish perspective there.
Yeah. So I want to make sure we have time for audience questions. So maybe one or two questions before we open it up. What aspects of satellites would you like to see standardized? I know, like Northrop Grumman, for example, I think Space Force adopted your refueling port. What are some other examples of things that you think should be standardized and universal across satellites, and why? And what does that mean for your business case?
Up until the last couple of years, we've all talked about a common interface, but everybody built their own thing, right? There was nothing that was common, even within a company, because it was really geared to optimize for the customer. But now we've turned the page on that now, and I think we really need to get to a point where, at least most automobiles have 4 wheels, right? There's not too many out there with 3.
Yeah.
Or 5,
Yeah.
unless you're a truck. But, I mean, there's got to come to a standard set, and people like Cosmic and, what's the new one, are working towards standardizing the interfaces that are required for any kind of servicing. And I think we're going to be there pretty soon. I think in the next few years, everybody will adopt, maybe some reluctantly than others, but what all the requirements are that need to be for a USB connection or what frequency you're transmitting at, or whatever the case might be. I think we're getting pretty close to that. Certainly in our lifetime, we'll see that.
Standardization.
Yeah.
Yeah, there are certainly benefits to standardization, right? Predictability, any asset, I'm going to know it has the interface that I'm already working with, its mate on the ground. I think there are hazards to pushing for standardization as the industry is early and nascent, and these capabilities are not yet mature across, if we take a wider look at industry. I think a great case study in standardization in commercial space is the CubeSat. Who invented the standard of the CubeSat? I mean, to my knowledge, it was eventually arrived at as people realized this is something that works, and it became almost a norm of the way that we built small, experimental, quick and cheap satellites because these were components that were readily available. I think if we're going to aim towards standardization or standards, however you may wish to look at this, why don't we focus on performance? Let's have performance-based standards that govern, whether or not a customer is willing to purchase or willing to engage with you, rather than hardware-based standards. At Starfish, we like to talk about operating from first principles. If my objective is to rendezvous and dock with another spacecraft, you can think about it 2 ways. Okay, let me go build a specific interface and then require that everyone install it on their spacecraft. And then, once they all build it and they all launch and then they start to fail, 7 to 12 years from now, I have a commercial market. If my objective really is to rendezvous and dock with and then move a spacecraft from one orbital location to another, in the near term, maybe a first principles approach says, well, let me just creatively solve the problem of how to dock with it now, which is what we've seen Space Logistics pioneer at the beginning and the path we're pursuing at Starfish. If we could get to standard hardware interfaces in the future, that would be great, but I want it to be because slowly, over time, the industry has had time to innovate and to try out different approaches in a safe and controlled manner, but not because a specific interface was mandated by a governing body or a regulatory body too early. So that's my standards soapbox. Performance-based standards, I do believe, are superior to hardware-based standards.
Yeah, interesting perspectives here. I think like top up or top down versus bottom up, and you're strongly advocating for bottom up, kind of organic. All right, so we didn't at all we didn't really get to talk about the assembly or the manufacturing aspect, but I wanted to ask.
You've got to do that.
Yeah. All right, so I'll ask one question, and a very short question. Manufacturing in space for space or manufacturing in space for Earth? Which is more promising? Keep it brief so we can get the audience.
Space is right now is only, remember, space is big.
Yeah.
But space is limited right now because of what you can fit inside a shroud. Even with Starship or something larger, we're still limited by what's under that shroud. And I always use as an example, I have a nice chart, I always show it when I'm briefing, that the Hubble spacecraft telescope's mirror is about the size of this stage. The James Webb that we built for NASA is the size of this room, right? And the next one that we're designing right now, you can either call it the HabX that NASA's looking at, or the LUVOIR that we're studying for them right now. The LUVOIR's mirrors are the size of this floor in this building, right? I had 157 different things that had to happen right for James Webb to deploy after being origamically crammed under a Ariane Spas shroud. And by the way, they did a fabulous job getting it to exactly where it needed to be. And to have that thing unfold and latch and and little bells go off and all sorts of things are happening, which took days, actually weeks. Every one of them, there's a few snags along the way, but we were able to fix them in space. If I had hair, I wouldn't after that because I would have pulled it all out. It was very nerve-wracking, very risky, great design, took decades to get that thing to where it needed to be. We just can't do that again, right? Particularly if I'm building something like Louvre the size of this entire floor, because it won't fit. I have to build it in space. I have to. And Northrop also is working with the government on a thing called SPIDER. We call it Fort McHenry, which is a solar power farm in space for beam transfer. And that system is the size of a football field, right? The solar panel. Can't get that under a shroud. No. So you build panels the size of these panels and you take them to space and you plug them all together. Yeah. And the metrology is very critical, and I mean, it's not an easy thing to do. But the only way to make that system, which the government has invested with us for about 5 years now, way before we even had any potential of being able to plug those panels together, foresight on their part, credit to them, to make this system eventually in the 2032 timeframe operational. I mean, you can't do that unless you make it in space. So, all right. Long answer to a...
But resounding manufacturing in space for space.
For space.
Yeah, all right.
Yep. Oh, it's so hard to choose. Obviously, we know that there is all the customers are on Earth, right? Anything we do in space is for people. And that's why, obviously, the legacy telecom providers in GEO are so interested in life extension. Their users are here on Earth. So obviously, that makes in-space manufacturing for Earth very interesting economically. I have to lean toward the sci-fi answer, though, for the in-space assembly for space future. I think what we're working on at Starfish relies on and is driven by our autonomous rendezvous proxops and docking algorithms. Our co-founder, Dr. Trevor Bennett, kind of pioneered these algorithms to allow us to execute all of those maneuvers fully with electric propulsion in his doctoral research. The advantage of chemical propulsion, obviously you have a lot of agility. You can move very quickly. The advantage of electric propulsion is you can be very efficient and perform many, many tasks over a long period of time with like a shit ton of fuel on board your spacecraft. I think that if we can nail the docking problem very gently and very precisely with electric propulsion, that's going to open up in-space assembly, especially with very exquisite components that are required for these large telescopes. How exciting would it be to see the next James Webb or the Roman telescope, maybe not the Roman telescope, but one of the next great observatories assembled in space, not having to be constrained by the fairing size of any one spacecraft, as you were just describing. None of that is possible if we cannot maneuver gently and with great precision with electric propulsion, I think.
All right, so it sounds like Starfish is going to get into this in-space assembly type stuff.
Yeah, stay tuned. Yeah. Catch me a couple decades from now working on
that. Take questions from the audience now. We literally can't see you, so if like the people with mics can go around. Yeah.
Yeah, hi, Mark Skinner, the Aerospace Corporation. Large LEO constellations, that's what we like to say.
Okay.
Also,
good to see you, Mark.
CubeSats were invented, if you would, by a couple professors in California, Jordy and Bob Twiggs, on a napkin at a restaurant. 10 centimeters is designed because it's trackable by the Space Surveillance Network. That's not my question, I digress. So on-orbit servicing. Some of the on-orbit servicing tasks include refueling, but I think we know that that could be problematic because, and this is obviated by mission extension vehicle, it's not just the fuel on a spacecraft that wears out over time. The harsh environment of space wears out the wheels, wears out electronics, et cetera. And so by refueling, you potentially have a situation where you've now got a satellite that can't be unpassivated if it fails due to some other problem that it has. So my question to the panel, there's no right or wrong answer here, is who do you think is best qualified to determine whether a commercial owner-operator should be able to refuel the spacecraft, especially if it's aged, it's like 15 years old or something like that. There could be other issues, so we don't want a floating bomb, and we've seen a few floating bombs up there if you watch the exoanalytics videos. So who should make the decision? The owner-operator has obviously maybe a conflict of interest. I leave it to you, the panel, to answer.
That is where the simulations come into play. And you're absolutely right. A lot of people say, hey, if I can just refuel this forever. Whoa, you can't refuel it forever. There's things that are going to wear out that takes more than just the fuel, right? I have to worry about the exit nozzles and various things along the way, the rate gyros. Again, if you get to a point where I'm visionarying here, but if I can take a Buick in space and change enough parts, I can turn it into a Mercedes, right? If I change everything, one at a time, right? Maybe it's not an economic thing to do, but you have to know that it's more than just the refueling. I think we've got the refueling thing pretty well understood, but now we're expanding to, okay, what else needs to be done to make sure I really can refuel that and it can last for another 5 years? It's not a trivial thing. It's perceptive to understand that's an issue. And that's where the robotics really comes into play. It's not just the refueling, a port coming together and pumping hydrazine across or whatever, xenon, but also being able to make sure everything else is operating properly. And if it's not, replace it.
Mm-hmm. Yeah, Mark, your question got very philosophical very quickly. Whose job is it anyway? I don't know if I have an answer to that question, but what I can tell you is in my conversations with operators of LEO spacecraft and large constellations, they seem very knowledgeable about their own spacecraft, and obviously they have incentives not to opt into a service that would end in disaster. So by and large, I think we can trust them to make a decision that's right long term. Obviously, there's always risk. And also, thank you for the history recap on the CubeSat. Did have an inventor, if not a mandated standard.
All right, maybe one last question.
Yes, good morning. Ian Dargan. My company is Iron Star Engineering, and we're looking at a solution to remove space debris. And I know that's not the subject of this morning's talk, so I want to get to my question, and that is, I know Alex mentioned dual use as a way to go, but to more or less emphasize the commercial aspect. So historically, it's been the Defense Department that takes the risk and puts the money up front to get things going, to kind of prime the pumps. And I don't know if that's still the way it's going to go, but with OSAM as a overall focus, which one? There's a number of questions that I have, and that's that internationally. We have to get something going. We don't have the regulatory. You mentioned that it might be too early for regulatory action, but in terms of getting something going, right now it's the Wild West, and we don't have good focus on getting things accomplished up there. And we, the United States, can operate, but then we still will need international buy-in and international cooperation. So my question is, with OSAM, all of the different various services that are be provided, which one will really be the one that opens things up to incentivize more regulatory action and more formal operations in low Earth orbit? Thank you.
I think first we need to come up with a solution. The whole conference, and there are some that talk nothing about space other than space debris. So we can talk about space debris and all the things associated with that, but there's at least, I'd say, 2 or 3 dozen companies right now focusing solely on space debris, both at a microscopic level and all the way up to picking up spent stages. So we have to let those things mature more before we actually start doing demonstrations. And once we do, then we need to get with our international partners and make sure, one, that we stop blowing things up in space and causing more conjunctions, but at least being able to confine and uniformly go after what we need to do to make it happen. We're talking with a company called Transastra that's got a capture bag, and it would be on board our MRV, and we would deploy it off one of our arms, and it would be it's designed to capture a variety of different debris and enclose it, and we take it and either put it in graveyard orbit or put it into a reentry trajectory. So, I mean, things are happening in that realm, and I know several international companies that are working to do the same thing. So we've got one that we're working with, but we're monitoring many that are trying to work that problem. And yes, it is an international thing, because if we just do it and they don't, we're not going to be any better off.
Free business idea. I want you to recycle that debris.
Yeah.
I mean, great job answering the question. I think the fear is looking at other domains. A lot of regulations end up being written in blood, right? Like we don't make the regulation until the catastrophe happens. And now here I find myself potentially on the side of regulations. I think that if we can increase awareness of the risks and incentivize adoption of our services, that might help us, prevent a situation either where we get into a catastrophic collision in, hopefully not Leo, and where those regulations need to pop up very rapidly by regulators and policymakers who maybe don't understand the problem very well. Something else to kind of your lead up there about like the role of government investment in this and that. I think something that's very exciting about commercial innovation is so much of our development is funded by VCs and what we would call like internally developed rather than non-dilutive government contributions. What that means is that when the government decides, okay, now is our time to step in and acquire the capability for a small investment, they're getting the same capability that in years gone by they would have spent 5 or 6 times that amount of money to acquire. So maybe the idea that leveraging VC and the commercial market to bring these incentives to operation more quickly, could incentivize more DoD acquisitions on a shorter timeline, which I think is what we're starting to see, which B, will prevent, hopefully, us getting into these collision scenarios. I hope that made sense.
All right, so we've gone over time, but I wanted to thank our panelists for great discussions, great points, and I think give them a round of applause.
Thank you.